Hello everyone, I hope you are doing well. So in this video, we are going to discuss the first 5 problems of Code Forces Round 895, which was rated for Division 3. So I believe like today's contest was pretty balanced for a Div 3 round, and I still did not manage to solve the last 2 problems. I believe I should have at least solved problem F. But anyways, let us quickly start with the problem discussion now. So the first problem is very straightforward. It says that we have been given 2 different vessels. The first one contains A grams of water and the second one contains B grams of water. And we also have an empty cup to store up to C grams of water. Right. Now both of the vessels have unlimited capacity. This A and B only denotes the current water present in that particular vessel. So in one operation, what we can do? We can take this cup and scoop up to C grams of water. So if you want to take 1 gram, you can take. You want to take 2 grams, you can take any amount up to C grams. Right. If you take from one vessel, you have to pour it into another vessel, and the water poured does not have to be in integers, so it can be in decimals as well. Now we have to tell the minimum number of operations to make the water in both of the vessels equal. Right. So this problem is very straightforward. If you see, so for example, this contains A grams of water, this contains B grams of water. These are 2 different vessels, and there is one cup that we have, and it has a maximum capacity of C. Right. Now this might have some water in it, and this might also have some water in it. Now we want to make the water in both of the vessels equal, right? So first of all, what we can do, we can calculate the difference between the two. So if I calculate absolute of B minus A, this is going to be the difference between the 2 vessels. Now let this be equals to dx, right? So this dx means, let us assume that B is going to be greater than A. So this means that the second vessel has dx grams of water more. And if I want to make the water equal in both of them, what I can do, I can take half of it and transfer it to the first vessel. Right. So this is exactly what I am going to do. What I will try to do is, I will try to take dx by 2 grams of water from the vessel which is bigger and try to pour it into the other vessel. Right. So how many steps will I take to move this much amount of water from the bigger vessel to the smaller vessel? So this is actually going to be dx by 2 by C value. Right. So these will be the total number of steps that are required for me to make both of the vessels equal. So whenever you want to calculate A by B seal value, what you can do, you can also write it as A plus B minus 1 divided by B. Right. So this will help you to keep all the calculations in integers, and the final answer will also be in integer. Right. So I am telling you this particular method only because we would always want to avoid floating point numbers, because there might be some errors or precision errors in floating numbers. That is why we are going to take this particular method. So our final answer will be dx plus 2c minus 1 divided by 2c. Right. So this is all you had to do in this particular problem. So now let us have a look at the code. So you see what I've done is, I've taken 3 integers a, b and c, and I've multiplied c by 2. Right. Now I calculate the value of dx, which is going to be maximum of a comma b minus minimum of a comma b. Right. Now I calculate my answer as dx plus c minus 1 by c. Since I've already multiplied c with 2 here, so I don't need to write 2 with c here. Right. And at the end I can just print my final answer. So this would be the solution for the first problem. Now let us have a look at this second problem. So basically this problem says that we are present at the first box, right? So let me just take this and I'll try to explain you this particular problem with the help of this example. So you will see what we have here is, we are currently at this first position, right? Now there are certain traps laid out on our way, right? So one trap is here, let's say one trap is here and one trap is here. Now each trap is associated with a value, let's say C, right? So as soon as you enter this particular cell with this trap will get activated exactly after C seconds, and once it is activated, you cannot enter this particular cell, right? Now you have to find the farthest distance that you can go to the right, such that after going to the right, you can also come back to your original position, which is the starting point, right? These are all the things that is mentioned in the problem. So now let us see with the help of this example. So let me just have this array. So let's say you have a trap here, and the value associated with this particular trap is 2. So that means if you are coming to this particular trap from the left side, and as soon as you enter this particular trap, the timer will get triggered, right? Now to move from one adjacent cell to the other one, you take 1 second. So if you go to the right cell and come back, right, so you will not be able to come back because exactly 2 seconds will have passed, and after 2 seconds this trap will get active, right? So when you go to the right, your 1 second has passed, right? And when you move back to this particular cell, 2 seconds has passed. But since 2 seconds has already passed, you cannot come to this particular cell. This is what the whole problem says. And now we have to tell the farthest distance that we can go. So by observation, you can find out that the maximum distance that you can go for the current trap will be equals to the position of the current trap plus C by 2 seal value minus 1. Right, so this will be the maximum distance that you can go, and let us see how. So let's say this was extended one more to the right. So let us take an example where the value of this trap is 3, right? That means it will get closed after 3 seconds. So at 1 second I can go here, at 2 second I can go here, and if I try to come back at 3 second, I'll only be able to reach this particular cell, right? Now let us try to go only till one cell. So at 1 second I'll come here, at 2 seconds I will come here, and at 3 seconds I will escape from this particular cell, right? So that means for when the value of C is 3, I can go one space extra, right? So that is the maximum position I can go to, and you will see if you try to fit it in this particular formula, it will be exactly that particular number, because 3 by 2 seal is going to be 2 and 2 minus 1 is going to be 1. So that means you could have gone one step extra. Now if the value of C is equals to 4, if the value of C is equals to 4, you can go up to one step. Let me show you how. If the value of C is 2 and you divide it by 2, you take the seal value, it is going to be 2, and 2 minus 1 is also going to be 1. So that means you can only go up to one step. So let me show you here also. So at 1 second you will be here, at 2 seconds you will be here, and at 3 seconds you will be here, right? But if you try to go one step extra, let's say at 1 second you are here, at 2 seconds you are here, at 3 seconds you will be here, and at 4 seconds you will be at the position of the trap. So that means that is not possible. So your answer will always be, for the current trap, the maximum distance that you can go is the position of the current trap plus the time associated by it divided by 2 seal value minus 1. Right, now you can calculate the maximum positions for all the traps that are given to us in the input, and your final answer will be the minimum values among them. Right, so let me show you the code of this particular problem. So here you see what I've done is I've created a vector of pairs, and it is of size n, and I've taken input in the vector. Now I am sorting all the values of v, although it is not necessary to sort, but I just still sort it during the contest, and I will initialize my answer with infinity. So infinity is just going to be a very big value. Now what I do, I am just traversing through all the traps, and my current answer is going to be the first value, that is going to be the position of the current trap and the value associated it by 2. So as I've already told you in the previous problem, when we want to calculate the seal of a by b, we do a plus b minus 1 by 2. Right. So in this case, I have done I dot second plus 2 minus 1, and that is going to be plus 1 essentially divided by 2. And at the end, I do minus 1. So I take the minimum of current answer comma answer, and I just print the answer value at the end. So this would be the solution of the second problem. Now let us have a look at the third problem now. So this particular problem says that we have been given two integers L and R, and we have to find two positive integers a and b such that the following conditions are simultaneously satisfied. Right, so the two conditions that have been given to us are that the summation of a plus b should be in this particular range, and the GCD of ab should not be equals to 1. So this problem was also not very difficult, and they also say that if the answer does not exist, we have to print minus 1. So let us see how we can solve this particular problem. Now let's say we have two values L and R, right? These are the ranges, and I want my sum a plus b to exist inside this particular range, right? Now let us assume R itself is an even number. So if I take 2 comma R minus 2, right, I am assuming that R is going to be an even number, and if I take this particular value 2 comma R minus 2, the summation of both of these values is going to be R, and their GCD is going to be 2. Right, so this is a guaranteed, because if R is even, then R minus 2 is also even, and the GCD of any even number with 2 is obviously going to be 2 itself. So if R is even, then I know my answer will definitely exist, and it is going to be 2 comma R minus 2. Now let us assume that R is going to be an odd number. Right, so if R is an odd number, I can try to find any prime divisor of R. Right, So in the first case, I directly took 2, right? But instead of 2, you could have also taken any prime divisor of R. It is not necessary to take 2. I just discussed 2 because in even numbers, 2 and R minus 2 can obviously be one of the answers. But in a more general scenario, instead of just finding 2, you can also find any prime divisor of the value of R, right? So let's say if the value of R is odd and there exists any prime divisor of R. So my answer is going to be, let's say that prime divisor is P and R minus P. So if I'm able to find any prime divisor of R, my answer is going to be P comma R minus P. Because if R is divisible by P, then R minus P will also be divisible by P, and the GCD of P comma R minus P is definitely going to be P, right? Now we have found two values such that their sum is equals to R in this particular case and their prime divisor is P. So this is one of the valid solutions. Now let us say that this value was odd and we were not able to find any prime divisor of this odd value. So what we can do is we can go to R minus 1 if it is allowed, right? I'm again saying we can only go to R minus 1 if it is allowed. When will it be allowed? When L is less than R, right? So if L is less than R, we can also try to form the sum equals to R minus 1, right? Now, if R was odd, then definitely R minus 1 is going to be even and we can form our answer as 2 comma R minus 3, right? We just have to make sure that this value R minus 3 is greater than 0. Other than that, there will be no issues with us. Why? So let me just discuss this part again. If R is odd, then definitely R minus 1 is going to be even and I can form my answer as 2 comma R minus 3. So the only two things that we need to take care of is that L needs to be less than R if you want to consider this case, and R minus 3 should also be greater than 0 because the question mentions that we need to find positive integers. So this was all about this particular problem. Now let me just discuss the final approach. So we are going to take the value R and we are going to find any of its prime divisor. So let's say it has a prime divisor P. Now my answer is going to be P minus R minus P because their GCD is not going to be equals to 1 and their sum is equals to R. Now let's say R is an odd number and it does not have any divisor. Now in this particular case, I can try to form the sum equals to R minus 1. I can only do it if L is less than R, because if L is equals to R, then my range for the sum is going to be starting from R and ending at R. So I cannot form the sum R minus 1. If I am allowed to form the sum R minus 1, my answer will definitely be 2 comma R minus 3, because if R was an odd number, R minus 1 is going to be an even number and my answer can be this, right? And I just have to make sure that R minus 3 is not equal to 0. So this was all about this particular problem. Now let me show you the final code. So you see what I've done is I've taken two integers a and b and I'm just trying to find any prime divisor of b. So if a prime divisor of b exists, it should exist till root of b. Now if I have found that particular prime divisor, I'll find two values x and y as x will be equals to I and y will be equals to b minus I, right? So if this exists, I'm just going to print x and y and I'm just going to return from here. Now if a is not equals to b, then only I can try to form the sum equals to b minus 1 and b minus 3 should also be greater than 0. So if both of the conditions are true, I can print 2 comma b minus 3 as my answer. Otherwise, I'm just going to print minus 1. So this will be the solution for this particular problem. Now let us have a look at this D problem. So this problem says that we have been given two integers x and y, right? Now we have to form a permutation of size n such that when we take all the positions which are multiples of x and add them, right? So for example, in this case, they have taken x to be equals to 2. So this will be the multiple of 2, this will be the multiple of 2, and this will be the multiple of 2. We want to take all of these positions and add the values in them. Similarly, we take all the positions of y and subtract those values from my answer. So these positions are going to be 1 and then this particular 4 because they are at positions 3 and 6 respectively, right? So if I do this particular calculation, my answer should be maximum, right? So this is my whole problem. I'm repeating it again. I have to take all the positions with multiples of x as positive integers and all the positions with multiple of y as negative values, and when I add both of them, my value should be maximum, right? So this is our whole problem. Now let us see how we can solve this. So let's say you have any general value n. So n is going to be the size of the array. So let's say x is going to be 2 and y is going to be 3, right? So this is going to be x1, this is going to be x2, this is going to be x3, right? And this is going to be y1 and this is going to be y2, right? Now, in order to maximize my answer, there is one thing for sure. I want to maximize the value at these positions which are only multiples of x, and I would want to minimize the values at these positions which are only multiples of y. What about these positions which are multiples of both x and y? I don't care about these positions because they are anyways going to neutralize each other. Now I am also going to ignore these positions because they are neither multiple of x nor multiples of y, right? So I don't care about these positions as well. The only positions I care about are those which are only multiples of x and only multiples of y, right? Remember, I am going to ignore these common multiples because even if I take them, let's say a value a was here, they are going to neutralize themselves because x will contribute a and y will contribute minus a, right? So we are not going to talk about them. Let's say we have this one position which is only the multiple of y. I want to minimize this particular position, that is why I put the smallest number here, right? Now if I have multiples of x, I would want to maximize these positions. So if I had in this particular case 7 elements, right, so I would want to put the maximum values here, right? So this is how you can form your final answer. My final answer is going to be 7 plus 6 minus 1 and it is going to be 12, right? So you see, what I'm trying to do is I'm trying to find out what are all the multiples of 5 and not including the common multiples obviously, and I'm also taking into consideration what are all the multiples of x, obviously excluding the common multiples. So how do I find the number of multiples these values have? So I can find the multiples of 5. First of all, I can find the multiples of 5 as n by y. I can find the multiples of x, mx is equals to n by x. I can find the common multiples mxy by doing n by LCM of xy. So these are going to give me the count of multiples of y, of x and x comma y together, right? Once I have all of these values, to find out the multiples of y only, I am going to subtract mxy from this. To find out all the multiples of x only, I am going to subtract mxy from this, and this way I'll be able to find all the answers. Let's say we have 5 multiples of y, so I'm going to put 1, 2, 3, 4 and 5 at these positions, right? And let's say I have 3 multiples of x, I'm going to put n minus 1 and n minus 2 at these positions, right? So you have to find the summation of these values and you have to find the summation of these values. So your final answer is going to be this x value and minus this y value, right? So this will be the solution for this particular problem. Now let us have a look at the final code. So you see, what I've done is, first of all, I have taken 3 integers nx and y, and if both x and y are equal, that is when my answer is going to be 0, right? So this will act like a base condition and you can just return from here. Now I calculate the value of mxy as n by LCM of x comma y. So LCM is going to be x into y divided by GCD of x comma y. This is just a simple formula that x into y is equals to LCM into GCD. So if I want to find LCM, I'm just going to take this GCD into division, right? Now I can find the value of mx as n by x, my as n by y. So mx is multiples of x and my is multiples of y. So in order to find only multiples of x and y respectively, I am going to subtract the common multiples from both of them. Now for the value that I have to subtract, my my is going to be my into my plus 1 by 2. So this is going to be the summation of first n numbers. So if I wanted to subtract the first 5 values, I am going to put the smallest 5 values, that is going to be 1, 2, 3, 4, 5, and their sum is going to be my into my plus 1 by 2. Now similarly, I have to take the last values for x. So you can safely ignore this calculation. I was thinking something else during the contest and I just complicated it a bit. But what you can do is, first of all, you can add this particular value to your answer, that is n into n plus 1 by 2. Now let's say you want to take the last 3 values. So your count here will be equals to n minus mx, right? So mx is the number of values that you want to take for x. So instead of writing count is equals to n minus count, you can write mx is equals to n minus x, and then you can subtract mx plus 1 into mx by 2 from the answer value. So I complicated this part a bit, but let me just explain you here. So let's say you have these 3 values, right? So the value of mx here is 3, right? If you calculate the value of n into n plus 1 by 2, this is going to give you the summation of 1 plus 2 plus 3 plus so on up to n, right? But you just want to take the summation of the last 3 values. So what you do, you set your mx as, you will set your mx as n minus mx, So now your mx is going to be n minus 3, right? So if I subtract the summation of all the values from 1 to n minus 3 from the summation of 1 to n, your final answer that you will get is equals to n plus n minus 1 plus n minus 2. This is exactly what we wanted, right? So you can solve this problem this way. I just like messed it up here a little bit, and then you can print your final answer. So this would be the solution of this particular problem. Now let us have a look at this problem, which is data structure span. So I solved this problem with segment trees, and I'm not sure if there exists a solution which is simpler than segment trees, but I believe if you are aware of what a segment tree is, then this solution would be very easy for you. Understanding my solution is not difficult, but my implementation of segment tree is something what you might struggle with. So if you have already studied segment tree, then it would be very easy for you to understand. If you have not studied segment tree before, then I highly recommend you to listen to my approach and then consider segment tree as a black box, right? I'll explain what are the features that segment trees offer us. I'll explain you my approach, and then you can consider it as a black box, and also I'll leave the template for my segment tree code in the description. So if you want to play with it, you can also try it, right? So this problem says that we have been given an array of integers and a string s consisting of binary characters. So those characters are going to be 0 or 1. Now there are two types of queries. The first query is 1LR. So in this particular query, we have to flip all the bits in the string in the range L to R. That means all the characters in the string that are 0 will be replaced with 1, and all the characters that are 1 will be replaced with 0. Now the query of the second type is 2, G. So in this query, what we have to do is, in the whole array, we have to print the XOR of all those values which have the corresponding character in S equals to 0. So let me just explain you. For this, for example, in this particular case, n is equals to 4, which is the size of the array. This is the array itself, and this is the string. Now you will see that the first index and the second index are marked with 0 positions. So if I make a query of type 2, 0, then I'll have to print the XOR of 2, 3, right? Because the characters corresponding to these positions are 0 in the string S. Now if my query would have been 2, 1, then I would have to print 1 XOR 6, because the corresponding character in S for these particular numbers is equals to 1. Now these are the only two operations that we have to deal with, and we have to find our final answer. So let us discuss some observations about this problem first, and then I will show you my code. You might be thinking that you might need to calculate the answer for these two queries separately, right? 2, 0 and 2, 1. But you will be very surprised if you realize that you only need to find the answer for one of them, and the answer for the other of them you can easily derive, right? For example, we have four numbers A, B, C and D, and the corresponding characters are 0, 1, 0, 1. So if my query is 2, 0, my answer is going to be A XOR C. But what if my query is 2, 1? I know that my answer is B XOR D, but how can I derive this value from this particular value? Since I am calculating the XOR in the whole array, what I can do is I can take the XOR of all the values with this value, A XOR B XOR C XOR D, right? So if I want to calculate the value of 2, 1, or I want to calculate the value of XOR of all the positions having 1, then I can take all the positions having 0 and taking the XOR of the whole range, right? So how will this help me? So you will realize that this A is going to cancel this particular A, and this C is going to cancel this particular C, and my only answer remaining will be B XOR D, and this is exactly what I wanted. Now one very important observation, that for this particular problem, the query of type 2 is only asking the answer for the whole array, right, or the whole range 1 to n. But even if they wanted the answer for some range L to R, then what we could have done is we could have taken this particular answer and taken with its XOR with the XOR of the range L to R, and that would have given us the answer for this particular query. So this was about how we can answer the queries, but how can we update the array, right? So if I have been given a query of this particular type, how can I update my whole array? So before diving into that, let me discuss some of the features of segment tree. So segment trees will help us implement two very important features, that is updating the range L to R in log n time, and querying the range L to R in log n time, right? So these are the two important features of segment tree that we are going to use. So we know that we can update in log n time, but what do we actually need to do while updating? So you will realize that when we are going to update any particular range, their bits are going to get flipped, right? 0 will convert to 1 and 1 will convert to 0. So essentially, if I want to say that the answer for 0 for that particular range is going to get converted into the answer for 1 for that particular range and vice versa. So let's say we had a range L to R and we performed an update on this particular range. So for this particular range, the value of X, let's say this was the answer for 0 and the value of Y, let's say this was the answer for 1, right? Now these two values are going to get flipped. So if for the range L to R, we know that the answer for 0 was X, we can just take its XOR with prefix of R and XOR prefix of L minus 1. So this is actually the XOR of all the elements in the range L to R. And if I take its XOR with X, I am going to get the value of Y, which was the XOR for all the values if it was equal to 1. So if they are switching places, then I can replace the answer for X is equal to 0 with this particular value. This is the only update that you had to perform, and whenever we query our segment tree, it is always going to give us the answer for the bits containing 0 at their respective positions. Right, so this is all you had to do in this particular problem. Let me just discuss this last part very quickly again. So what I am trying to say is that if you have the answer for 0 bits, then you can always find the answer for the bits that have 1 in their respective positions. Right, so I am going to use the segment tree to store the answer for each range containing the 0 bit. Right, now whenever I want to flip the bits in any of the ranges, so in that particular range, the answer is going to get inverted. So for example, if this ABCD was like this and this was 0 1 0 1, so the answer for 1 previously was B XOR D. Now if I flip all the bits in this particular range, it is going to be 1 0 1 0, right? So this B XOR D is now going to be the answer for positions which have 0 in their respective places, right? So I just have to replace my current answer with the answer for 1 in the same range. Right, if I do this particular operation, then my segment tree will get updated. So this is all you had to do, and there is one very important topic that I wanted to mention, and that is lazy propagation. Right, so how does lazy propagation helps us? Lazy propagations is the actual thing that is going to help us in updating the range L to R in log n time. With segment tree only, it is not possible to update this whole range in log n. Only with lazy propagation it is possible to update the range in L to R. Now you could have also used Fenwick trees or anything similar which helps you to update and query in lock-in time. But I have used segment tree because I already have the template of segment tree. I am going to show you how the segment tree looks like. You can also ignore it and consider the segment tree that I have used as a black box, or once I am going to explain, you can also try to understand it, and I'll also leave a link to the template I am using for segment tree for you in the description, and you can always have a look at it. So if I show you my final code, you will see what I have done is I have taken an integer n and I have taken the input in the vector v. Now I have initialized my prefix vector and I am just going to store the prefix of XORs. So this I minus 1 is only because of 0 based indexing vector v, and for prefix array I am going to take 1 based indexing. Right. Now I have taken the string s as input. So this is my segment tree template, and you can also find it on my GitHub. I'll leave the link in the description. But let me just tell you one thing. The link that you will find in the description has the template for sum queries, right? So it is going to find you range sum, not range XOR, right? So you will have to take care of this particular thing. Now, if you see, I take the queries as input and I am taking the operation as input. Now, if operation is equals to 1, I have to update this particular range L to R, and I'm just calling my update function. Otherwise, I'm just calling my query function, and if g is equals to 1, I'm going to take the XOR of this particular answer value with prefix of n. Since I have to display the XOR from the whole array, that is why I'm taking the prefix of n here, and at the end I can just print my answer value. So this was all about this part, and from here on you can just ignore this segment tree part if you want, because you can also consider it as a black box. But if you want, you can also follow up my explanation with this particular segment tree. So since I have already explained you that I am building the segment tree for all the values where s of I is equal to 0, right? So this segment tree is going to be 1 based, and you will see inside this build function when low is equals to high, that means I have reached one position. What I am going to do is if s of low minus 1, Since string S is in 0-based indexing, I am using low minus 1 here. If it is equal to 0, then only I am going to update my segment tree value with V of low minus 1. Again, V is in 0-based indexing, that is why I have used low minus 1 here. So if it is equals to 1, I am not going to consider it because I am taking all the values with positions in S equals to 0. Right. Now I calculate my mid. I call my build functions on both of the trees, left half and right half, and I'm going to update my sec tree of node as sec tree of twice of node, commas, XOR sec tree of twice of node plus 1. So basically this is going to store the answer for low to mid, and this is going to store the answer for mid plus 1 to high. Right. Similarly, in my update function, if my lazy tree of current node is greater than 0, that means I need to update my current node, and I'll update my current node with the XOR value of lazy tree of node. Right. Now, since I want to update the left half and the right half as well, I'm going to calculate what is the value of XOR that I need to pass on to the left half. So it is going to be the XOR in the range low to mid, right? So I can find it as tree of mid XOR tree of low minus 1. Similarly, I need to find the value of XOR from mid plus 1 to high. So I'm doing tree of high XOR tree of mid, right? So if low is not equals to high, I'm going to update my lazy tree. This is the left half of my current array by XOR with left. This is the right half of my current array. So this is going to be the XOR with right, and I update my lazy tree of node as 0. So if you have not studied segment tree, I'm sure that all of this would be making no sense to you. But if you have studied segment tree, then I'm just walking you through all the changes that I have made in a normal range sum segment tree. Right. So all the places in which we take sum, I have taken XOR here. And similarly, the same thing goes for this particular part. This is the part when your current range lies exactly inside the range that you need to find the answer for. For this, you would want to take the XOR with the XOR of the current subarray, and I update my sec tree of node as XOR with need. So if I have more elements on the left and the right halves remaining, I'm going to update lazy tree for that particular nodes. Right. So this is the update function, and this is my updating of current node. Similarly, goes for query. I just needed to show you how these lazy update functions are done. So the query is very simple, similar to the update functions. And if you still have any other queries, please drop it down in the comments. I would be more than happy to answer those queries regarding this particular segment tree. But I highly recommend you to study the basics of segment tree first. Only then you would be able to understand this last part of the explanation. Right. So I hope that you guys were able to understand the solutions. If you guys did, then consider dropping a like on this video, and don't forget to share your thoughts in the comments, because your engagement with this particular video really helps the YouTube algorithm to understand that this video is actually helpful for you, and it will be able to reach much more people like you who want to keep solving new problems. So I see a lot of people who watch these videos have not subscribed yet. In case you're one of them, then definitely consider subscribing. It's always free of cost, and you can also unsubscribe if you don't find the videos interesting later. So share the channel with your friends. Until the next video drops, keep coding, stay safe, bye bye.